So essentially, when it says verify the identity, it's just make one side look like the other. Like use the trig functions. I believe the ones in the notes are the reciprocal functions, the Pythagorean identities, and the quotient identities. We're going to use one of each, as it turns out, when we do the question. So having those available to you is essential. So I'm going to flip back and forth and show these, but as you're working through more problems on your own, have these available to you, right? Again, it's just a matter of making one side look like the other. What this problem is going to force you to do is to make the left side look like the right side. You could go the other way. If you're doing this on your own, like if you're doing this on a written test for me, like I don't care. Make one side look like the other. But this is set up that we're making the left side. We're going to turn the left side into the right side using those properties. So the first thing is we're taking cosine theta minus secant theta. All right, so the left side. And we're first going to change something about this. So what can we do with secant theta that might be helpful? Just look at your toolbox. There's not a lot of secant in here, right? The one here is secant theta is equal to 1 over cosine theta. Secant is the reciprocal of cosine. So I'm just going to write that down here. What we're using is secant theta is equal to 1 over cosine theta. So that's going in the box here as my first step. All right, so let's type that in. It's a fraction. So it's 1 over cosine theta. And what allowed us to do that was a reciprocal identity. That was the name, reciprocal identity. That's what we used here, right? So a reciprocal identity. The next thing we're going to do is combine those two functions. And the way we're going to do that is like anytime you're adding or subtracting fractions, you need a common denominator. So if this is currently over 1, it needs to have a denominator of cosine theta. When you multiply cosine theta by cosine theta in the numerator, same thing that would happen if you multiplied x and x together. X times x is x squared. Okay, cosine theta times cosine theta is cosine squared theta. The squared goes on the function, not the angle. All right. So now they have the common denominator, you can subtract them. It'll be cosine squared theta minus 1 over cosine theta. That's what's going to go my answer here. So it is a fraction. So cosine, I need to input the exponent of 2. That's the angle, minus 1 cosine theta. And then the reason we were able to do that is we were able to combine them using the least common denominator. Okay. All right, now that we have cosine squared theta in the numerator, we're going to use a theorem to handle that. You know, over to all my identities and properties and stuff. The only one that has a squared in it is that one, the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. We're going to use that. All right, so sine squared theta plus cosine squared theta equals. I need to manipulate that identity to make it look like cosine squared theta minus 1. So if I subtract 1 from both sides, I get sine squared theta is cosine squared theta minus 1 equals 0. I'm then going to subtract sine squared theta from both sides, and I get cosine squared theta minus 1 is equal to negative sine squared theta. All right, so cosine squared theta minus 1 is equal to negative sine squared theta. So that's going to be replacing my numerator, right? This equation. I'm going to replace cosine squared theta minus 1 with negative sine squared theta. Numbers unchanged. We apply the Pythagorean identity. That's the one we used. Okay. Essentially, this next step is just, it's already telling you that negative sine squared theta over cosine theta equals the negative sine theta tangent theta at the right side. So we've effectively turned the left side into the right side, thus proving it to be true. The only thing you need to answer now is, what's the reason that allowed you to go from what we had, negative sine squared theta over cosine theta, to negative sine theta tangent theta, okay? So if I write it out, negative sine squared theta over cosine theta, I can rewrite that fraction. That sine squared, I can break it into two. I can say it's negative sine theta times sine theta, denominator unchanged. The reason why I can do that, sine theta times sine theta is sine squared theta, right? Just like x times x is x squared. You can break apart x squared into x times x if you want. That's useful here. I can break apart sine squared into sine times sine, all right? Reason why that's useful is, look at what the quotient identity, tangent theta is equal to sine theta over cosine theta. So the quotient identity, that's telling me that tangent theta is equal to sine theta over cosine theta. If I just focus on this part, that sine theta over cosine theta can turn into tangent theta. The negative sine theta is still there, thus giving you exactly that. So what was the thing that allowed us to do that? We rewrote as a product. So we rewrote the sine squared theta as a product of sine theta times sine theta. And then we used a quotient identity, right? The quotient identity was the sine theta over cosine theta. We split it apart so we could use the quotient identity to get it down to tangent. That was still left over. And there you go. All right. I get this is tough. I wish I was there to teach you in person. Keep asking me questions. If you need to ask a bunch, right? No problem at all. All right. So take a look at this. Hopefully this helps. See if you can apply some of the things that I talked about here, some other questions. Definitely send me more questions if you have them. Okay.